Okay, we are going to continue with the next slide now. We're discussing about measured number, and in the meantime we were also discussing some of the physical properties. One of the examples, just to refresh your memories, we were discussing about density. Physical property can be calculated as ratio of mass over volume. So we're going to do some calculations related with density. In the previous video, I was showing you how to use directly this formula, which is density is mass over volume. Now we're going to see the next relationship. Let's say that if volume is given to you, and also density is given to you, and you will be asked to calculate the mass. Okay, let's say that the volume of the substance would be, we can pick ethanol or acetone, some kind of organic compound that has let's say that it has a volume of 25 grams. I'm just picking the numbers here, and then the density would be like 0.71 gram per milliliter. All right, and then we'll be asked to calculate the mass. So if you look at the previous formula, density is equal to mass over volume. Mass can be calculated as density times volume. This can be a very appropriate formula to solve this equation. So we basically substitute the numbers that we have here. So the density is 0.791 gram per milliliter, and the volume is 25 grams. Okay, so we can calculate the mass, which gives us, I'm going to use basically my cell phone here for right now as a calculator. I don't bring my calculator, but we can use the cell phone. But remember that we always have to apply the rules of significant figures. So if you multiply 0.791 times 25, the calculator display will show you about which my cell phone shows me right now, 19.775. Okay, so 19.775 grams, because we're going to calculate the mass. And actually I was making a little mistake here. The volume, let's say that if we have the volume has to be, sometimes the volume has to be expressed in terms of grams, but for the sake of simplicity we can change this into milliliter. So we can have milliliter instead of grams. So what I'm trying to do it here is milliliter will be crossed out by milliliter, then you will have gram, which is the appropriate unit for mass. Now remember that we have again 1, 2, 3, 4, 5 significant figures, but we would like to have at least 2 significant figures because the volume that was given for you was 25 milliliter. So sometimes it's going to be a little bit confusion to round up numbers, but we have here 19.775 grams. If you round it up to 3 significant figures, it gives you about 19.8 grams. This will give you about 20 grams. Now again, we have zeros here. It's a little bit confusion, especially when you have zeros with no decimal points. There are 2 things that we need to make consideration. If you have 20 grams versus 20 grams, okay, in this case it has 2 significant figures. In this case it's very hard to say whether it has 1 or 2 significant figures. Okay, so what we have to do is you have to rewrite the number like 20 in a form of scientific equation or scientific notation. That way we can able to see that the final answer reflects the two significant figures. So we can say 2.0 times 10 to the power of 1 gram. This would be the best answer to write in the appropriate number of significant figure. Okay, I think we did a lot about significant figure and then the calculation density. Maybe we can pick another example. Okay, bear with me. This time, I guess we have to do converging factors. A lot of times, many students will have a problem of doing converging factors. So we're going to do some examples of converging factors. Let's start with a simple example. Say, for instance, we have a weight of, let's say, 25. Oh, sorry. A weight of 25 pounds, and you want to change that into kilogram. Okay, so 25 pounds is a US system. Kilogram is the SI system. SI means International System of Units. So in order to convert 25 pounds to kilogram, we have to use something called a conversion factor. In most cases, a conversion factor will be given to you. Let's say 1 kilogram equals to 2.20 pounds. You have to memorize this. In most cases, to be given to you. But what we need to know here is how you set up the conversion factor. That's very important. So the way how we calculate here is we write 25 pounds, which is a given value, and we set up the conversion factor in a way that the unwanted unit has to be eliminated. So remember that we have a plan here. We have a pound and we want to change pound into kilogram. So our destination is kilogram. So we're going to put 1 kilogram here over 2.20 pound. So the unwanted unit is pound. So pound will be eliminated by pound. So we can do the multiplication and the division, which means you multiply 25 by 1. Obviously, it gives you 25. And then divide that by 2.20, which gives you about, I see on my calculators, 11.36 kilogram. Well, again, you have 4 significant figure, and you like to rewrite this into 2 significant figure because the given value has 2 significant figures. So it's going to be 11.4 kilogram, sorry. And then it's going to be like 11 kilogram because the number can be removed because it is a number which is less than 5. If it is 5, it can be 5, and above 5 can be rounded to the next number. So the final answer will be 11 kilogram. This might be easier and straight and forward question, but there are sometimes some questions require more conversion factors. Okay, so let's look on the next slide, maybe to do some kind of calculation. Let's say that you have oxygen, the speed of oxygen. Oxygen travels in air, maybe like I would say 215 meter per second, right? We want to change that into miles per hour now, but I think I would make this in a different way. Maybe like, let's say that we have 215 miles per hour. We want to change that into meter per second. Now, why I changed this? Now, mile per hour is, like I said, it's a US system of measurement. Meter per second, this is something called SI system of measurement. You know, we have to be always convert units in SI systems. The reason why we want to do SI system, most literatures, most researchers have done by SI system. That's a system of international units. There are metric system, US system, sometimes called British system, and SI system. SI system is used all over the world. So what scientists have done that in order to avoid confusions among researchers, among students all over, students like you, they wanted to develop a unit that can be applicable everywhere. In Africa, in Asia, in United States, in Canada, in Australia, and everywhere, wherever you go, SI system is common. So I would suggest you to practice SI system as much as possible. So let's continue converting the US system into SI system. I'm going to go to the next slide. So we had 15 mile per hour, and we want to change mile per hour into meter per second. There's a lot of conversions here. So we have to first go that mile has to be changed into kilometer. Kilometer has to be changed into meter. That's from the top part, from the numerator part. All right. And from the bottom part, we have to do that. We have hour. Hour has to be changed into minutes. Minutes has to be changed into second. Okay, but the conversions will be given to you like 1 mile in the US system equals to 1.6093 kilometer. Also 1 kilometer equals to 1000 meter, and also 1 hour is 60 minutes, and 1 minute is 60 seconds. So 1 hour is obviously would be 3,600 seconds. You multiply 60 by 60. That's how you came up with this number. So how we do the convergence? The convergence can be done as 215 mile per hour. You see, the important point is the setup, how you set up the problem. Now you wanted to change mile into kilometer, so always put kilometer on the top because that's the required or the desired unit. So you use you may say that 1.6093 kilometer, okay, over 1 mile. And you want to change kilometer into meter, so you can say here 1 kilometer equals 1000 meters. So you may say 1000 meter over 1 kilometer. Okay, so far what we've done is from the top part, from the numerator part, and this part here is called denominator. The bottom part is called denominator. Now let's work on the denominator part. Make sure that on the denominator part, this is our unit plan here. This is, I would say, unit plan. This is our plan. The plan is mile has to be changed into kilometer, kilometer has to be changed into meter, and the hour has to be changed into minutes, the minutes has to be changed into second. All right, so what I'm going to do is I'm going to use 1 hour equals to 3,600 seconds, so I put 1 hour over 3,600 seconds. So before doing any mathematical calculation, we're going to remove the unwanted units. Okay, so you can see from here that hour is cancelled by hour, kilometer is cancelled by kilometer, mile and mile will be crossed out. What's left from the top is here, I'm going to write here, meter, on the bottom is second. Now we can do the calculation. Now when you do the calculation, we multiply, again I'm going to use my cell phone here, 215 times 1.6093, okay, times 1000 from the top part. So that gives me about 345,999.5. That has to be divided by 3600. Basically I would get something 96 0.11 meter per second. So this one has 4 significant figures. If I would like to round into 3 significant figures, I can simply say 96.1 meter per second. Okay, so this will be the final answer. Remember that the final answer also has 3 significant figures that reflects the original number here, which had 3 significant figures. Okay, so this is how conversions are done. I'm going to give you more conversions on the next slide as well, on the next videos. Thank you for watching for right now, and I'm going to continue post videos. I would like to say, please send me your comments, your suggestions, your ideas to improve my videos, to make it better, to make it more understandable for all of you. Thank you for your time to watch the video, and I'll see you in the next videos. Thank you.